I would be leading this session. Give us a few more minutes. We're going to start over the next couple of minutes. We had quite a lot of participants joining in, so we'll just give in a few minutes to them to just try to get on board, and we'll start off then. Right, so we will maybe a couple of minutes more and we'll start. Right, so just till then, just chill out. Okay, I think we're going to start. My name is Chinmay. I head a company called Arima Research. We are a pure data analytics, data science company and an exclusive partner with QAI, one of the premier operational consulting and strategy organizations in the world today. And in collaboration with them, we bring you this 1.5 hour webinar on demystifying analytics, where I would be taking you through a very high level introduction of what is analytics, how is it, the key definitions of it. I would be talking with respect to some of the techniques that I use, some of the algorithms that I used, what kind of a typical life cycle do we use in analytics projects, what kind of tools do we use, and certain use cases for sure, as well as the technology that are that comprises the whole stack. Right. I think the intent is to give you a very high-level view of the entire chain, as we call it, right? And that's what we intend to do. I'm sure you would have a lot of questions. It would be great if you could share your questions, and we will email you back all the answers individually. I think we've got quite a large number of participants joining in with us, which is also what we were waiting for them to get on board. So if you have questions, please do drop me a mail. I will be sending this deck and some related material across to all of you, right? And so let's start. Right. So what am I going to cover? I'm going to make this quite a session where I'll be jumping into different web pages and certain examples to show you, certain tools to show you. I have a few that I plan to take you through, but essentially to convey concepts across to you and explain what's really happening in analytics and algorithms. But first we'll start with what are the key definitions. I'm sure many of you would be hearing about data analytics, data science, data mining, big data. All the terms are all over the place. Not a day goes by without an article from either the global leaders in terms of organizations talking about it, or potential that we see, or just the explosion in its usage. Right nowadays, it's actually easier to quote an application which uses machine learning, data analytics, as either directly in the foreground or in the background, than to identify one which doesn't. Right. So we're going to talk about some of those. So what are the different components which constitute it? We're going to talk about that. We're going to talk about what's a typical life cycle, that's used in an analytics project. How do you solve it? How do you take care of it? Before in life cycle, we would also talk a little bit about defining what is machine learning, what kind of algorithms are used there, and all of those components. We'll talk about some use cases. We'll talk about some cases we have been part of or it's typically used in fields of HR analytics, in the area of operations, as well as identifying customer-related problems and challenges, and what key technologies. Right. So this is an introductory session, and obviously give an initial glimpse of what's going on. Of course, we can have a more detailed conversation as you go ahead and take it further. Right. So that's a planned coverage, and that's what we plan to cover in the next 90 minutes. Hopefully, we should be able to do that. Right. And starting with a very high level, kind of clarifying definitions. Let's say now we hear data analytics, data science. Now broadly, this is a larger umbrella. Call it a superset of techniques where you are trying to extract information from raw data, right? And and this includes everything from basic visualization and to building predictive model. Now, and I keep on facing this question a lot. That all of us have been doing this to some extent all our time, all our working lives. In many of our functions, we have been using this to represent information, to represent reports, and definitely many of you who have been involved in improvement methodologies like Six Sigma, or even for that matter any other improvement projects, have been doing this. Right? So is it something new? Actually, it's not. It's just a new term which is useful in describing this entire science, and I believe everybody has been doing some level of analytics and data science from a long time. Right. What has happened is, in this recent time, it has become more popular, right? And that's attributable to a huge explosion in terms of computing power, in terms of availability of resources that we have. I think one of the prime drivers of this has been internet broadband speeds. Right? You can stream information. You can download large data sets. You can do a lot of stuff on on servers which are on the cloud. So there's a cumulative effect which has converged into making data science a very popular term. That I've been using these applications. In fact, some of the most common algorithms that we'll hear about are not the ones that have been invented rather or created in the last 10 years. I think the most popular ones have been are the ones which have been created in 1950s, 1960s, 1970s, and have been in use since 1980s, but in a restricted context. Today, they have become democratized. They have become popularized. They have become accessible to everyone, right? And leading this wave of accessibility in terms of the whole process, there is this field of data mining, which is essentially the science, so the method of collecting a large set of data, understanding patterns out of it, right? and trying eventually to go into some kind of a predictive output tool. So this is like a smaller thing inside analytics. It's a smaller, you can see a circle inside analytics, which is a lot more concentrated to quite a large data set in a way. Right? So it's data mining with algorithms a little more sophisticated. Then inside it comes machine learning, which is again very popular term today. Machine learning, everybody is doing machine learning today. So it's again relates to the study, design, and development of algorithms. So this is very specifically algorithms that we're talking about, which helps machines or computers to identify patterns and learn from the data, the patterns and rules, without being exclusively programmed to do that. Right? So what it means essentially is, we write a piece of algorithm which essentially identifies what kind of conditions would be followed or are available in the rules for a certain output to happen. Right? So this kind of creating that algorithm which will automatically learn the rules comes under this field of machine learning. Quite vast. And obviously there are loads and loads of algorithms inside it, so we will see some of them and you will see the whole bouquet in a very complex diagram. I have that for the slides. Right, so and these are the algorithms which are used in other fields, so this is more of a subfield which links to artificial intelligence, which links to data mining, which links to many other fields, right? But here the focus is on creating an algorithm which is advanced, which uses a lot of advanced statistical elements to it, and which sort of optimizes the way we identify patterns, and more importantly, which doesn't have preconceived notions. It sort of learns based on the data that you provide. So data set A would create a certain set of rules, while data set B would create another set of rules. And this difference or agility that it provides makes it very, very, very useful, because then you really have something called personalization that is coming in, and not a very high level view of things. So you're not forcing things on top of it, right? So that's where machine learning is a very niche area that is being talked about, right? So all of them converge obviously to the overall area of data science. But the interesting thing is, data science has evolved to something, and we generally associate it now with business analytics, or what we call as a combination of computer science, maths and stats, as well as a domain expertise coming together and building your output, which is used by the business, right? So its use is essentially now getting integrated into a decision-making context. The accessibility of technology, the availability of information capture mechanisms, the availability of sophisticated algorithms and computing power is causing, and that's the wave that has happened, that we will integrate these, which will help businesses take decisions which have a direct impact, which is in a way the quantified decision-making process, the data-driven decision-making process. Right? Now, it's interesting to understand this. The reason why these three have come in. Now, when we're talking live decision-making context, when we're talking businesses or organizations taking decisions, we're not dealing with small amounts of data. We're not dealing with fixed amount of data. We're talking about a large, scope of study out here, right? So that's where you need, the maths and stats to come in to identify the patterns, to identify the rules out of it. Because of this volume of information, because of its need that business users have to use it, it needs a lot of, computer science in the back end to, for example, store the data in a database. So you need somebody with database expertise. You need to visualize the output in a UI. So you need somebody with an output or a web-based development kind of skills. You need somebody who can optimize the algorithm fetch and stuff like that. So you need somebody who knows the algorithm part of it, the machine learning, the math and the stats part of it. And that's where both of them converge to give you an output. But this output is still incomplete if somebody does not understand the context in which this has to be applied. And even that, for that matter, even identifying what kind of output would be required. Excuse me. Right? And that's where the subject matter expertise or the domain expertise comes. My ability, this becomes extremely critical. This is almost the pivot which holds, the whole system. You're talking about different domains, different fields, which have their own uniqueness, which have their own interpretations. And for business to take decisions, this uniqueness and interpretation also has to be captured and used. So a financial analysis and a analysis in a human resource context have to also bring in their domain knowledge to say that, okay, we want to predict attrition of resources. We want to predict whether somebody is going to default on a loan or not. Well, the algorithm might be the same. The way it is used, the kind of factors which will be used will depend on somebody understanding the domain to identify and penetrate. And that's where subject matter expertise becomes important. So it's a intersection of these three components which come together and forms what's called the analytics, data science, data analytics, or business analytics as we call it. Right? So that's now touching back to the point where I said that businesses or organizations, when they need to do all this, there's a huge amount of data, and this environment has changed phenomenally over. I'm sure all of us have been part of the story, and we have all seen it again and again and again. Right, our phones are capturing information at a massive rate, right from every tap and the click that we do to every tweet that we post, right? Every interaction on a messenger, if given the permission, you're all providing data. You're providing your images, you're providing, so all this information, there are lots of sensors which are built today which are collecting information and machinery, right? So there's a huge explosion of data that is actually getting captured. And in fact, there's this massive element of what we call as unstructured data that is also coming in. Right? Unstructured data is like not columnar, but in text data, or image data, all kinds of data that's coming in, and it's growing rapidly. Right now, obviously, these also have to go through this whole segment of processing to give you the output, right? To where you would look at faster decision making, a personalized experience, and stuff like that. I'm sure all of us have gone to Amazon or one of these e-commerce sites, right? And we see that the moment we buy something, it starts telling that people who bought this you may also be interested in something similar. It's actually a massive engine at the back end which is used an algorithm and identified based on my choice of product that I bought, what similar articles do other people across the world or in a similar cluster have been buying, right? So if you think back about it, it's a huge volume of information that we're talking about. You're talking about a massive volume of information. And that's where the algorithms are better, there's a faster processing speed. But the base of it is a huge volume of data that's massive. And that's why, so if we actually break this data volume part of it, we're talking about a lot of analysis which can be done on your smaller data sets. We can do a lot of traditional analytics, which we have been doing, descriptive analytics, first level regressions, and sometimes series and stuff like that, but smaller data sets. We can do a lot of advanced machine learning kind of things, still on smaller data sets. Okay, there are limitations, but you understand. We can do a lot of traditional analytics, like a simple trend analysis of, volume of tweets on a certain topic, day on day, every day for a last 1 month, right? So in our country, in India, we had this, huge move by the government to remove certain currency called demonetization, and then let's say if you want to track the comments and the sentiments of people, or track just the number of tweets which are posted on this, topic on Twitter across the last 3 months. It was announced from 8th of November till date. So how much volume? So that's a simple, run chart or an area graph that you will draw, but the amount of data is quite large, right? So you can do a lot of traditional analytics on this. But now you are entering the realm, and let me define the term of what is called big data. So big data, and a lot of times it's called big data analytics. It's essentially not only the use of advanced algorithms on a large data set. It's big data comprises a larger set where you are talking about collection, management, and processing of a massive volume of data, which is not GBs, but actually I think the line is not really doing justice. It's actually terabytes and above, with characteristics like volume. The volume is large, where you have a lot of variety. You're talking about images, you're talking about text, you're talking about in text, special characters with words, with short forms and everything coming in. And of course, there's a large velocity at which the data is arriving. right? And when on top of this we start using sophisticated algorithms like a recommendation engine algorithm, where you get recommendation for products, right? That's where we call it big data, advanced analytics. So that, it's not that you cannot use advanced analytics when you have a smaller data sets, certain MBs or, certain, say quite a bit of GBs, or maybe in Excel terms you will say, maybe I can we use, machine learning on something like 5,000 rows of data? Can we? Yes, we can. Accuracy? Well, we will have to discuss about that. Useful? Yes, of course it is useful. You will definitely there are algorithms which will maybe give you a very high level of, usable output. So that's a decision that comes in it. So this difference that I want to bring out here is it's not necessary that analytics is always a very, very large volume of data stored on a database. Yes, it can be very useful there. You can identify more patterns, but you can also do it on smaller data sets and data sets. When I mean smaller, I don't mean 20 rows of data or 40 rows of data. Trust me, we get a lot of questions on that also. Right. So big data is essentially defined by volume, variety, velocity, and of course, as we started using it and as the industry evolved, we came across another term which was called veracity, which is how certain are you of the data. In fact, it's very interesting. Many business users are not really sure of the accuracy of their data, right? Well, that makes things much more complex today. Right? Because if you're not sure of the accuracy and there's no way to figure it out, and I'm not talking about missing values, I'm talking about pure accuracy. So it's like, a web form being given to most of us, right? And instead of my email ID, I fill it xyz@gmail.com. Right? So maybe the form will just accept it, right? But it's something I don't know how to use it, right? I will enter my age at 72 years of age while my age is somewhere within 30s. It's completely incorrect. So the results of it would be incorrect. So building veracity of data is another important attribute which is attached to this term of big data also nowadays, because we are really talking about a large volume of data. Now verifying veracity of GBs and terabytes of data and petabytes of data is going to be extremely difficult, right? So that's another element that comes in, into the management of big data or the definition of big data itself. So big data is not always equal to sophisticated algorithms. It could be algorithms which are used, but it essentially tries to cater to this, absolute element of managing a huge volume of information and data. So that's where big data comes in. So a large part of big data technologies or skills are very technically computer science, database, related skills, advanced level of search, information retrieval kind of skills, skills which require understanding cluster computing and distributed computing kind of environments. Right? So that's big data. So analytics essentially is the use of statistical, mathematical functions or algorithms in combination with elements of computer science with domain expertise to give you business insights, right? So that's what we're talking about, right? So analytics is a lot of data connected with an analytical engine which drives decision to improve performance or manage risks, right? Just to take a step back and refresh, while big data has a huge emphasis on the ability of collection, management, and processing of data to give it, to feed it into the analytical engine and maybe show the results of it. Right? So it may or may not use the complex algorithms. It depends on the business itself. But essentially, at the end of it, a huge emphasis of this is analytics must be connected with the business output. Right? And it's true with most such principles that have been there. It's been forever been said that if there's no value and benefit, obviously it's no use using all this. Right? So that's where this whole connotation of analytics is becoming very useful, right, for people. There are three broad areas in this field of analytics that we speak about. You see this chart on, you see this chart on your right-hand side called bottom part, and you'll see there's something called descriptive analytics, predictive analytics, and prescriptive analytics. And essentially, you'll see different sizes of the circles out there. The different size essentially indicates the amount of usage in the industry. A lot of it is still concentrated on the descriptive part. Descriptive part caters a lot to understanding the past. It's helping businesses understand events which have happened across units, across functions, aggregating it. A lot of this has still always been used in traditional tools. A lot of business intelligence tools have been used. Has been using this. Excel has been the most popular way of doing this. There are other tools that may have and which also do a lot of descriptive analytics. Finding basic trends, patterns. That's where the focus is in terms of the descriptive analytics part of it. Using that information to go into the predictive analytics part of it is where we start predicting events, right? And going a step further, we talk about optimization in terms of decision making, in terms of doing trade-off analysis, in terms of identifying what if we change, what if analysis, trying to say what if we change a parameter, what kind of balance do I see between cost and the value of the output that I want to see. Right, so that's where prescriptive analytics comes in, and obviously its usage is complex. It is much higher over the value chain in terms of business value it adds, right? But it's quite complex. It's a very complex field inside analytics, and I think that's where most of the work is trying to be done today. So summary in terms of what kind of elements we talk about. So as descriptive would be overlap between hindsight and insight, right? While predictive and prescriptive is essentially foresight to the business, right? Obviously, increasing business advantage and sophistication comes in, and there is a lot of algorithms. Or I've given you high-level elements or categories of algorithms which are used out here. You have right from visualization in descriptive analytics, which goes up to simulation and modeling, to optimization algorithms like linear optimization and other elements which come into the predictive and prescriptive elements of it. Right. Now, essentially what I've been trying to tell you, many of these have grown quite a large element in the last 15 to 20 years. And a lot of this is attributed to this explosion in computing power, in the availability of machines, in the availability of, in the reduction of cost of, the whole computing power element that is also available. So there's a cost factor, there is a power factor which came in from a computing perspective, which made many of these algorithms start being usable, right? For example, algorithms which we can today run on our, laptops and, possibly high-end desktops, needed large servers, and some years back they needed supercomputers to be executed. Today you can actually do. There are cloud servers available for as little as $10, where you can take a $10 per month, and you can actually talk about 2 terabyte transfer speeds. So you can actually host an analytical operation, a basic analytical operation, of course, with some level of predictive analytics into it on the cloud, and have it available to people. Algorithms which started really going, into the next gen, which is where we talk about deep learning today and image recognition and all, which are the modifications which have come in, towards the late 2000s and era of it, and they're interesting, and they're doing a lot of, there's a lot of value that is doing, but again, they have the advantage of the computing power. So it's been a gradual move, and it has been a very, very interesting move where suddenly there is a huge explosion, and it's a combination of, you will see availability of computing power with, the need of the hour in terms of availability of data also coming. This leads us, so when all of these, descriptive, predictive, elements are coming in, especially the predictive and prescriptive elements are coming in, this leads us to this topic of what's machine learning. Remember, what I define machine learning is the branch which creates the algorithms that help the computers or machines to learn patterns from data without being explicitly programmed to do that, right? So it's essentially programmed as a high-level structure which sort of understands patterns based on the data, right? So it's a study of algorithms that improve their performance at some tasks with experience, right? It optimizes a performance criterion using some past data and experience, and that's also something which we'll talk about. And it's essentially the fuel that drives analytics, or this field of business analytics for that matter. Right? So a lot of analytics elements have been possible because the field of machine learning is now executable on black box, right? And this is primarily divided. The classes in which this machine learning is available today is divided into three broad, let me call it four broad areas, right? You have something called supervised learning, where you sort of, okay, so supervised learning is essentially like a teacher teaching us, right? So they have an experience, they have a knowledge of things, they teach us something, and we learn and apply that knowledge in a new context, right? So that's teaching, right? So it has prediction and classification. We'll talk about that. Classification essentially is a type of prediction itself, where we have a probability attached to it. We'll talk about that. Supervised learning, so it's essentially giving it a set of data, past data, historical data, so it learns the pattern from that data, machine learning, and then it uses it on a newer data set or on live context to identify it, telling that if the data had a similar context, then this is how the result should be, right? Second type is unsupervised learning. Unsupervised learning is you really don't have a prediction as a goal. It's more of identifying groups, clusters, or identifying similarity of patterns, right? So here you are not talking about predicting something. And another key element of unsupervised learning is you don't need something called historical data or training data. Here you essentially give it a data set and say, okay, from this data set, identify which factors or parameters are similar to each other, right? And that's essentially what clustering will do a lot, which are bunched together. And this is not a function of a single parameter. So imagine it's, you have an Excel sheet where you have age, location, gender, and certain output, which is value, let's say. And you can filter on location, you can filter on age, and you can do a lot of filtering and say, okay, this is what kind of value that I see. Right? Now imagine if I want to say, I don't want to do it on single such parameters. I want to identify my records which are grouped together as a function of all four variables. Right? And what kind of groups do I see? Right? So that's where clustering comes in. A combination in real life, many times we combine supervised with unsupervised learning, and it's called semi-supervised learning. Right? The fourth type, which is where you're seeing a lot of news today, is reinforcement learning. This is essentially the algorithms which are used in the self-driving cars. In the one that I'm sure you read the article a few days back about a machine or an artificial intelligence computer beating the best Go player and the chess player and the poker player. It was IBM's Deep Blue machine beating the I think one of the chess champions there, right? So this essentially goes into a realm of reinforcement. What you are trying to do here is you are allowing the algorithm to sort of go through an experience, execute it, make a mistake, and then put it, incorporate that learning, and next time try to avoid it. So for example, if you have a self-driving car, you keep on making the car run multiple times, right? You let them hit obstacles, which is extracted into the algorithm, and say, okay, I hit an obstacle, which is where you say that there is a penalty to it, and you're not supposed to do that. And when you miss it, you give them a reward, right? And this sorts of makes the algorithm becoming smarter and smarter, and after some time, it starts driving through a whole series of obstacles that has been put in front of them. Of course, so essentially it's an algorithm which processes all this data from sensors telling that you're going to hit something, you're hitting an obstacle, or it's a camera which is taking hundreds of images in terms of the markers and the lines, and teaching itself to do that. Right? So that's reinforcement learning. It's one of the areas where there's a lot of research going on. I'm sure all of us have been hearing about it from all the top companies of the world, and extremely complex element, but of course the business value is right up on top. Right? So classes of algorithms, supervised learning, you give it a data set, it learns the rules from it, applies it on a new data set. Unsupervised learning, no historical data, essentially identifies, runs a algorithm to identify similarity of instances, right? Which group of customers, what attributes of people, for example, will default on loans, right? What attributes of people would, are leaving the company. And I don't want singular attributes. I don't want a, it's just in unsupervised learning, you are, removing that restriction, telling that I'm looking only at age. Not necessary. What if the decision of people to leave the company is a function of multiple attributes? It is that right age group with his current marital status, with the current performance bonus that he got last time, with the rating of his performance that he got, the last time that he went through the appraisal. So essentially it may be a combination, and real life decisions actually are a combination of facts rather than telling that age is influencing the outcome. Maybe it does, but it may not be the one with the highest power to tell you or impact your decision making abilities, right? So that's unsupervised learning. Semi-supervised learning, combination. Reinforcement learning is making the algorithm learn by repeating experiences, right? So supervised learning, so a little bit more detail of supervised learning. It essentially is to predict the future. It has labels, as we call it, or named elements, and you sort of generalize it. You learn by, you move from a specific data set. So you induce a general set of rules which is applied to a larger data element, right, while the labels remain similar to each other. That's called induction to generalization. Examples: decision trees, classifiers, Bayesian classifiers. There's something called support vector machines. Awesome names. There's something called neural networks, which sort of mimics the way our brains work. In fact, one of the higher forms of neural networks is what we call as deep learning today. So neural networks has something called filters, right? And if you go into those filters, if you increase the number of filters, you will come to something called as the deep learning architecture. Right? So if you're interested to know more, just do a quick search and you'll see lots of articles. You could also visit our blog page, blog.arimaresearch.com, and you'll see a couple of articles on neural networks also. Right. But before we go further, let me try to show you how it really works. I hope you're able to see this screen of mine. I will send you the link when I send you the presentation of it. So this is essentially what a supervised learning does, right? And I'm going to scroll slowly so that you see something. Now the problem is I have a data set which has attributes of housing prices, and it has, for example, attributes like what is the elevation level, what is the price of per square feet. It has how many rooms and bedrooms it. So all of these attributes are collected, and my objective is to identify whether what would be the the price of the house, and whether it is if in New York or whether it is located in New York or San Francisco. So the colors indicate the houses. So you have some in San Francisco. The green ones are the ones in San Francisco. The blue ones are the ones in New York. So usually when we start, we do a first level analysis. We say, okay, so how much data do we have? What kind of descriptive value do we see in terms of the data that we have set? Remember, our predict output functionality is that I should be able to, I have a historical set of data which identifies for me, depending on elevation, number of bedrooms, and many other factors, whether this house is in San Francisco or New York. My objective is that tomorrow if I give a new record which has all the parameters like elevation, number of bedrooms, price per square feet, and all these others, it should be able to tell me whether the house is in San Francisco or in New York, right? So that's my objective. That's the prediction I want to do. This kind of an algorithm is what is used in many of the housing kind of websites, because obviously it's very difficult to individually go and ask every house in the locality what's the pricing and where and all that is there. So something similar to is what is extrapolated to be used out there, right? So first, a basic level of analysis. I'm trying to see who's lying, what kind of relationships do I see. These are individual correlations, and and I'm sure you all know about it. Elevation between year built, number of bathrooms between bedrooms. So do I see a relationship? Do you see some kind of a linear correlation? That means that when the number of bedrooms increases, the number of bathrooms will actually increase. Obviously, we think that's what happens, right? And then we start seeing, where is it that, remember this, we are trying to do an unsupervised, we are trying to do a supervised learning and something called classification, because we are classifying into buckets, right? So when I have a new data set which comes in, I want to classify whether it is in the green bucket or it is into the blue bucket, right? So I'm trying to see, okay, so where is it that these things happen? So finally, it starts giving me, so when I run my algorithm based on the data, it's machine learning, it runs the rules, learns the rules from the data, it starts building a net like this, right? It starts telling if the elevation is less than this, then go here. If the price per square feet is less than these values, then go here, and then that's how it goes, and hence you are red or blue or green, right? So that's essentially what the classification does. Now once I've got the rules, I will try to see if the rules are accurately classifying my existing data set, which is my historical data. So is the kind of rules really making sense if I try to test it on whatever is existing, because I know the results of it, right? So I sort of test it and I see that, well, you know what, it's pretty good. It's very good actually. It's 100% accurate. So if I get this set of data running on it, it's quite okay. So it's learned properly in a way, right? And then I take another set of data which I would have kept it aside, for whom I also know the results. I can't deploy it directly onto my business decision making context without really testing it out properly, right? So one level of test is I create a test data set and I say, okay, I know the result, but I'm not going to tell it to the algorithm. I will just push in the data. Now you see the data is coming in and I want to see how is it classifying. Is the blue going into the blue and the green going into the green, right? And that's exactly what we want to test and see how accurate this is. If you see, there are some greens around here, right? And there are some blues around here. So that means now I have an accuracy of 89.7%. So sometimes you can say, well, that's good enough, but I have a problem that, this is a kind of a small error here, that, it was too specific to that context, right? So, but essentially this is what a classification does. It splits data. Now, when it is learning from the data, it is not assuming, and that's where, it's learning from the data. It's not assuming that every classification is a linear classification. It's not, it's a straight line separating the two data sets. It could be, non-linear also. So that's where its advantages and complexity comes in, right? So that's essentially what classification does, right? And this is an example of what we call as, supervised learning, and what you saw was specifically something called decision trees. There are many other ways which sort of deal with depending on the complexity. Unsupervised learning doesn't require a specific label, and more of a self-guided algorithm. It sort of builds groups, and sort of clusters similar groups or similar data points together, and sort of says, okay, let's see a pattern around it. Right. So a lot of these are used, in applications in many business scenarios. In many of our business scenarios today, it's either a use of supervised learning, unsupervised learning. Of course, when you go to the higher levels of better reinforcement learning, there are specific use cases around that. In reality, many times we sort of combine them, and that's what we say that it's a semi-supervised learning. Yeah, that's what's been happening. Well, that was broad categories, and I was telling you that I've named a few, and you see the whole slide getting filled with, and these are all the algorithms that are available, which can be used in different contexts, depending on the business problem. Okay, so there's a lot of algorithms, right? So one of the questions that keeps on coming, so what do we use? Well, the computing power is cheap. So why don't we run through a set of algorithms and then identify which gives us the highest accuracies and sort of use that, right? And that's the approach that we use most of the cases. But of course, depending on the data and the business problem, whether it is a classification or whether it is a regression on a continuous value as an output, or is it an unsupervised learning, of course, there is some narrow down that happens, but end of the day, once we have narrowed down, we'll still have many choices. And so we prefer to sort of run it over multiple algorithms to see if we can increase the level of accuracy. Now, the prime driver behind it is this is the results of this is going to be used for business decision making. Now you can't make a business decision by telling that, you know what, I am like 60 to 65% sure of what is going to happen. Right? So that's not acceptable from a business context, and we need it as closer to the higher benchmarks as possible. Upward of 80s and 90s and all this is where the aim is, and what we achieve needs to be a combination of algorithm possibly, or multiple algorithms run one after the time to find out what works best. Right. So that's where you sort of run for all these algorithms. Right. Typically, when you start, that's more of the algorithms and things that we're speaking about. Very quickly, most of the analytics projects follow a life cycle called the CRISP-DM, which is the cross-industry standard process for data mining. It's a process which is used and it has been very popular. In fact, it is one of the most popular life cycles that is in use. Of course, there are modifications that are made, but again, this is one of the most popular one. It starts with business understanding, which sorts of lays out what's the kind of objectives that the project has, what is it that you want to achieve in terms of targets and stuff like that. Collecting that initial level of data and collecting, reviewing the data in terms of quality and what kind of usability is available. Many times, we think we have a lot of data, but in a specific context of business problem, we find that many critical elements are lacking. Right, so that's one element that needs to be identified and evaluated. There is preparation, which involves cleansing as well as some level of transformation, or you want to combine two elements and create a third data element out of it. There would be creation of the models, the modeling part of it. And obviously the models will be evaluated. If you remember the graphic, we evaluated a model. And of course there is deployment to the business, and that itself is a consideration of whether it has to be web deployed or how to do it. It's very important to understand this deployment phase, because many times we sort of think that that's given, but it's not. Remember, the users of it have to take business decisions, and they may not be as familiar or as conversed with all the statistical complexities that have been used while modeling and evaluating, right? So they may need to be provided in easier, web-based interfaces, which sort of help them take intuitive decisions, right? For example, I'll show you an example in a few seconds. And that's also where some level of computer science and web-based engineering has to come in, because you need to really take the output and sort of render it on a web page where you can do drag and drop, or see a visualization or show the outputs and things like that. Right. So for example, one example I'll quickly show you was, okay, this is slightly complex. So here I have a look. Let's say this is using some kind of a similarity matching algorithm. This is an unsupervised clustering, unsupervised learning, where I'm doing some bit of clustering based on skill profiles and multiple other factors, where I'm telling that, okay, and I want to identify which skills, which people are sort of related in skills. And let's say if I'm a business user, I mean, this is too complex, so maybe I want to do some selection. And I want to see, okay, are there skills? So I have a group of people for skills, but I don't see any of them overlapping, right? So this is not something that's going to be useful for me, right? So I may say change and say, okay, let me see if I can change something. And if I want to have a set, here are three skills, Java, C++, and Python, where I have a set of people who overlap. And if I'm a business user, I might simply want to click it and say, okay, I go and see his profile and stuff like that. So that's essentially what I meant by making a UI-based element to it. Or, for example, identifying correlation between or relationship between different blood tests that I see, massive volume of data, and I want to see if there are patterns available, right? So what we use here, what is called a market basket analysis or an association analysis, which is a kind of an unsupervised learning, essentially to identify a lot of content behind it, right? So if I start seeing association behind it, by seeing, okay, which tests are typically to be taken together, or which values are together, and if I want to see it by similarity of output, I want to see it by values, and the colors indicate a certain meaning, so these are negatively related. So essentially this is helping the business users quickly identify that, okay, here I have a series of tests, between these four elements which are actually quite strongly related to each other, and then go ahead and I identify why they are related, right? So that's what I meant by deployment here. Now, there have been questions to me in the past telling that this seems like any improvement methodology, so why crisp DM? Especially many of you who have been from the disciplines of Six Sigma and others, will say that identify with it very naturally. And you're right. I mean, in a way, you don't really, have to confirm as a must. But this was a different discipline where a lot of people who involved were, from computer science backgrounds and other business function backgrounds. So while Six Sigma was there and people knew it, they followed. That you can easily follow the DMAC life cycle here and still execute the project and get the output. There is also something for people who don't know and say, okay, let's follow this, which is fine. It's a choice, but it's really not something that's make a difference. One thing, however, which I want to bring to your notice is, if you notice, a lot of these lifecycle components are looping back. So essentially what it means is none of these life cycles are sequential in step. They keep on going back into a continuous level of loop backs and feeding it back to click, repeat. You need to repeat it again and again. For example, you'll be doing modeling and you suddenly realize that you need to go back and create another level of transformation. Right? So you go back to the data preparation phase and create a transformation. Now your lines are very blurry, but essentially you are repeating stages. Right? So they're not really sequential where you think that once I have finished a stage, I am not going to go back. It's not, doesn't happen, and I'm sure all of you know that that's how real business problems occur and behave when you're trying to solve them. Right? Most effort, unsurprisingly, is not in modeling, not in deployment, but in data understanding and preparation. In fact, even today, where we have been consulting many corporations across India, Western Europe, and Hong Kong and China, most of our time goes in cleaning data. Right, and it's just not null values, it is errand values, it is the spelling of a city in 4 different ways, something like, for example, London being spelled as London with L caps, with L small, with LON, with Great Britain coming in sometimes in between. Now, and the problem is similar if you use it in an Excel spreadsheet also. There are 4 filters that are created here, although the value is the same. Right now, imagine this problem when you are dealing with 500,000 rows of information with 40 columns and stuff like that. This is a real effort-consuming element. And of course, you can't proceed because all results will go awry, models will fail, queries will not work. So you have all of those problems that come around and manifest itself, right? So a lot of time and effort typically goes around data preparation and data understanding. Modeling, it's solved to quite an extent as long as you know what to apply, because many of these users have started building libraries, and I'll show you some of them how they work. So it sort of eases it out, right? Okay, talking about a few use cases. Where have we been using this stuff, right? We've been trying to answer questions like, are we attracting the right customers? What's the most successful channel of sales? How much are my loyal customers buying, or are my loyal customers really loyal? That's an important question to answer. Just because they signed up for my loyalty card, it's not that they become my loyal customers, right? So, who are my most costly customers, right? How can I predict the ability of a client to click on a certain product and actually buy it? Right? So you can do an unsupervised learning here and identify, for example, what customers are similar in their buying behavior of certain products, right? Based on different attributes of gender, demographic attributes, buying behavior, time of purchases, and multiple other stuff. So a lot of questions, business questions. The focus is identify the business question first and then take it further to the next level, right? Of course, another element that we use is in the HR domain, where we start looking at prediction of key resources and what factors are causing it, right? This is a supervised learning where we sort of build a decision tree and identify, is it a combination of multiple factors, which is called, and what is the probability of an individual actually moving out of the organization, right? So that's where we start looking at, from a prediction perspective of key resources, right? And many more in the HR domain. HR, in fact, has a lot of interesting data. It's a combination of text, a lot of text data is there, a lot of data about personnel is available. So it becomes very interesting for us to derive insights there, right? And obviously you all know that HR is one of the most critical functions, right? So attrition, demand. One of the recent projects that we did, and in fact I think it's a case which has got selected in the Harvard Business Cases also for academic institutions, is when somebody is offered a job, whether they will accept and join it or not. Right, so that's another thing that was a classification problem which we did. We had around 94% of accuracy to it used, and it gets refined as you start feeding in more data to sort of see how it is done. Right, so that's one level of engagements in HR analytics, use cases that you can use. You could also do a lot of analytics on survey results, not only trying to understand how the basic survey parameters are, but also trying to identify relationships. Right, so yeah, we spoke about segmentation, lifetime value, credit scoring, all of these on a customer. So the previous slide was in the HR domain. This is more of answering customer-based questions. Right, could do a lot of that. We could use one of the things that we are seeing is most of the outputs, right, are increasingly using visualizations to be demonstrated. So, the ones like the ones that I showed you. So visualization is also coming in, and it's also getting called something as visual analytics, where it's cross-domain, but we want to see outputs and patterns in very innovative way rather than a standard pie charts and bar charts, right? So that's an area news that many organizations are focusing upon. Right. So, and of course, I told you in the beginning, it's very easy to find out, many people where analytics is used in daily products and anything, right? Excuse me. I think one of the simplest uses that, or rather most common, I wouldn't say the simplest, but most common is the Google search engines. You type a few words and it starts telling you what would be your next word. I think it has become so, if I can use the word omnipresent, that we don't even consider that, or we don't even reflect that it is actually predicting something which is, so very, very complex. It's an extremely complex element, because, if you think about it, it's most of the time it's literally the third or the fourth sentence that it is suggesting it's what we are searching for, right? So it's pretty complex one. So another example of a product recommendation which you spoke about. Okay, so image analysis. I think you would have all noticed this. When you upload your pictures in Facebook or Picasa for that matter in Google, I'm sure you would have all noticed that it suddenly starts kind of identifying the name of the person, based on the picture. And many times now it is of course improved quite a lot. So it's quite accurate. And that's a classification, a supervised learning, because previously you would have uploaded an image and named the person. So now it is able to correlate and say, what, this person is of the similar nature. Even if the picture is slightly sideways and not exactly the same picture, right? So that's image analysis. Again, a kind of a classification problem. So usage of this is absolutely, getting into every element and domain of our lives, and organizations are getting exponential benefits. But of course, it's not a path which can be done in a day, but it takes time, and there are business cases which have to be evolved. The initial genesis always is the business case, and that's where the key, I would say the key clincher of this game lies. Identifying the business cases, identifying a plan for it, takes it further. Right. What kind of technologies do we use? Let's say if you want to start off and how we want to do this, our most common elements that we use. One of the technological platforms that we use is something called a language called R, and which has an IDE called RStudio. RStudio looks very similar to this. I'm sure you should be able to see this on my screen. So let me just expand this a bit. So what you see here is a window where my console or the code is written. This is where the execution happens. This is like the code, I'm running a simple time series forecasting element. And I'm trying to sort of see that, okay, here is what my actual results were, and I want to predict what my future would be, right? And time series prediction is something that is upgraded with many other machine learning algorithms to sort of also understand trends, as you start entering more data. So, but very straightforward. You write a piece of code, it sort of runs on code here, and when you execute it, it pulls the data, and it sorts of plots your results out here. And this is, a kind of IDE or maybe one of the base elements, very popular, one of the most popular thing in the world, and it's completely open source, completely free, right? There are some IDE packages for some of us who are not very, comfortable in coding. Well, initially even I was not comfortable, but the moment you start getting into this, we all will learn the code part of it. I don't think that's something which is very difficult to do, but yeah, we will learn for it. We learn it and we will use it, right? So there is something called Battle. It's a very nice tool which sort of can help you do drag and drop kind of functions, which uses R as a base. And R is very popular because and again, like as I was telling about libraries, R is nothing new. It's been there from 1950s, 60s, and used primarily by academicians for statistical purpose. And certainly got a boost when people started looking for something very robust, because when they started using it, because it's programming based, it's one of the biggest advantages of it is that there are a great number of libraries and customized libraries which are available to do lots of modeling scenarios and lots of things around that. So that's one of the advantages where we have something like R coming in, and very popular, very, very popular, right? One of the other tools is something. It's a programming scripting language called Python. Very popular IDE for it, or rather you can call is something called Anaconda. I've not mentioned here, but it's called Anaconda, which is more of a whole set of things which make things easier in Python. You can also, like I wrote the code in R, you could write it and script it in Python. There's a similar IDE for Python called Rodeo. Again, open source. One of the advantages of Python, of course, nowadays even R has something on a web-based interface, but one of the advantages with Python is that it has this, it's because it's a web programming language where applications can be built on web, so it makes things a little more seamless, when your models are in web and you want to sort of do it. Plus, the new fields of text analytics, deep learning, and all have sort of better libraries in Python, although that difference is rapidly closing between R and Python. So not all tools and platforms are script code based, but there are a lot which are sort of user interface drag and drop. Some of them quite popular also. You have something called SPSS from IBM. There is SAS, very, very popular tools. These are licensed versions. Then there is another very nice tool which is drag and drop kind of an environment, like a workflow, which we call KNMIME. Interesting tools. There's quite a lot of infrastructure around it, and obviously, compared to scripting ones, they have their advantages and also their disadvantages. The scripting tools give us the flexibility to do as we are. Some of these are black boxes, so we may or may not be able to sort of customize or do whatever we want. So there's a kind of a trade-off that has to be done over learning curve time versus flexibility and agility of use, right? So that's kind of a trade-off required, but yeah, and of course the scripting tools have an advantage of being open source. Right. Now, but these tools like Python, R, and all are mostly concentrated on the algorithm execution part of it, right? But if you talk about a whole stack or layer, analytics would involve some level of data handling elements like SQL databases or NoSQL databases or Hadoop, which are very, very large systems, right? So Hadoop is like a primary file storage element. where you're talking the big data kind of environment. You have NoSQL, again a big data kind of environment. No difference between NoSQL and SQL is that NoSQL does not require data in column sort of structured format. You can say unstructured formatting as objects also directly there, or a good old Excel and CSV. So data is saved somewhere. It would typically come into an analytical engine. The analytical engine could be built using scripts like Python, Scala, Ruby, RC, or SPSS, the ones that we would use, whose output would be a visualization based on, of course, very popular tools like Tableau, ClickView, JavaScript, or something like D3.js. D3.js was the kind of libraries we had used for the visualization that you saw. So. And obviously some of the basic, and this is when we are talking about taking it right for the deployment part of it, right? Of course, interim graphs and all would be generated by the R libraries and the Python libraries and stuff like that. Right now, there are organizations like Google, Microsoft Azure, there's Watson from IBM. What they have done is they have made it a lot more drag and drop clickable, and they've integrated all these platforms and offer analytics as a service. Amazing set of tools. These elements are Google Prediction, Azure, including Watson. There is another very nice one called Big ML, right, which really makes it very easy for non-coders but more of business users to actually experiment and even build production level models. Watson is doing great stuff on AI and prediction of cancer and stuff like that, where you could just integrate the engine and to start predicting. So of course, they do come with a cost, and sometimes it's quite large, but it depends on the business case and the value that you're looking at. And they make things quite easy, where they integrated all these stacks, so you don't have to spend the time building all these components for you to use them later. So that's one of the advantages that we have. Right. So that's broadly the technology stack. There are, of course, challenges that we have been facing. I think one of the biggest challenges facing organization has been, deriving insights, right? So many times, and I think this was the result of a survey which was done recently. One of the things that we can start seeing is that, how do we derive insights? Raw data is like crude oil, right? You pay $50 for a barrel, but the moment you process it, every element is much, much more expensive than that. You have petroleum, you have perfumes, you have Vaseline, you have so many other things from that same barrel of crude. Right, but it has to go through that layer of processing. So data is like the crude, where analytics is the refinery, and your output is the value that you get, the insights that you get. So many organizations struggle. That's primarily because although they feel they have a lot of data, I think it's a combination of resources. It's a combination of knowledge and skills, and it's also a combination of what point do you start. Have we defined the right business cases, right? So that's where it becomes very important to start defining when and how we would use something like analytics. Obviously, with this whole chain, we have to also identify that this has to be usable in a decision-making context. To make it usable, there is, will be a cost associated with it, and so the clearer we are on those elements, the better we are on that. Access to data. Many organizations are siloed. Even inside organizations, accessibility to information across different groups is restricted, right? And valuable insight comes when you start matching, cross-matching data, right? Because some part of data may be available in one unit and another part may be something else. For example, credit risk may be in one element, while the decision to give a loan, for example, returns or I'm just taking an example, but the payment history could be in something like some other application. So it could be application which are segregated. It could be divisions which are segregated. So getting access, pulling them together, and the applications may have different databases. So you need to invest on that to build it up. All of those challenges come in, right? And obviously the ability to manipulate and integrate the data. So all of these come together and really become complex. Most areas of investment we are seeing even today is in people. Training of people is another element that comes in. Investment in tools. Organizations are trying to identify what is the best tool. Many of them are going for custom development of some of these analytics tools on specific use cases. That's something we have been making, where we have been talking to, where we have, for example, if you want to predict something like credit risks or a level of visualization, custom tools that are getting built. So that's, of course, there is a lot of investment in infrastructures like IBM Watson or setting up a Hadoop cluster where they have their own people. It all is a function of the need and how they're investing. But that's again something that a lot of companies are investing in. Interestingly, data sources, especially buying external data sources, another area where a lot of organizations are sort of taking the leap towards. Right. So that's primarily what I had to cover. So just to do a brief recap. So we spoke about definitions of analytics, what it is, what is machine learning. We spoke about how we use the different algorithms of machine learning. You saw the animation of decision tree. We spoke and differentiated between big data analytics, big data and analytics. And we spoke about the life cycle, the CRISP DM, right? And we spoke about certain use cases that are used in other places, right? And of course, we did go into some of the technology elements and experiences, right? So that's primarily the introduction that we had planned to cover. If you have any quick questions, I would be able to take a couple of them. If you could send it on the chat window, and I think we can take a couple of them, or else if you want to drop in your questions, and in case I'm not able to take it up, I would definitely reply to each of these questions, and for sure I'm going to share this presentation with you. You would be able to download it directly from the website too, and of course I would be giving sending across a few other resources for you to just refresh some of the elements that we have discussed about. Right, so I'm open for questions. If you could just type in your questions, or if you prefer to send it by email, I leave it up to you. Otherwise, I think we have covered. So that's where we have covered the whole element of it. And so, are we getting any questions?
Hello.
Yeah.
Chinmay, please hold for a moment. I am sharing the questions.
Hmm.
Screen हो रहा है? Chinmay, please see your chat box.
Yeah. So okay. So we have three growth. How do you differentiate if the data is small or big? Well, I think it's a function of many things. I think data small or big depends on what is the type of data. Whether it is numbers or whether it is text. Very broadly, we talk about the size of data in terms of in terms of whether how many rows of data we have and what kind of objective of the business that we want to meet. For example, you might have, let's say 5,000 rows of data, but if your insight requires very high specification, or if, for example, let's take an example. Let's say I have a very high data volume, 50,000, 75,000 data set, right? But many of the rows inside have erroneous data or wrong data or blank data and all of those. So it's not 75,000 that I'm using actually. Right? So it's a context which has to be taken. It's in terms of it will be taken in the context of the business question at this moment. Similarly, text data. If you're taking text data, unless and until you have a lot of text data, when I mean lots, for example, if you take tweets, unless and until you have tweets for 15 days, 10 days, continuously monitoring, and if you have specific hashtag, if in terms of rows, if you don't have 25,000, 30,000, 100,000 rows, it's very difficult to get any credible insights out of it, right? So it's a context. Same 25,000, if I had an HR data set of people leaving the company or staying in the company, I think it's a great set of data. But if I take it up into text format, if I take it as a Twitter analysis, it may actually be limited because it may not be enough, or it may not be reliable enough. So it's a question, right? Very high level, you can say, okay, what's the number of rows, right? So that's something that sort of helps you do a first level differentiation. But yeah, it's always a tricky question which you and me as data scientists will always have to start. We will have to be the ones who have to take that decision and live with it. Right. So that's there. Tell me a little bit about unsupervised deeply. Allow me to send me a mail on that, please. It's a little broad subject. I would send you some resources around it. I'm sure you would like it. Growth in Tableau, well, I think as a visualization tool, Tableau is a fantastic tool because it's something which is helping many people do visualizations fast, right, and very nicely, intuitively. So in terms of, and especially with its advanced function in terms of integrating SQL, and even R can be integrated in Tableau. I think it is a phenomenal feature. And today, if you look at it, I think there's a huge kind of growth that we are seeing in terms of Tableau usage in many organizations. Tableau comes in multiple ways, right? So you have the server versions, you have the Tableau reports getting formed. So you need to identify what kind of skill, and obviously if you can combine it with some level of advanced functionalities in Tableau, there's a huge growth of that. Okay. Any idea if Splunk is an analytics tool? Well, Splunk is more of a platform which is typically used for log analysis. It's analytics tool. I would rather say it's more of it's one of the tools we use to sort of manage log data. That's what we've been using it for. Especially IT log related data or machine log generated data is where Splunk is primarily used. But let me check if it can be, if it is it's not traditionally a tool like R and all. I typically Splunk is used in integration with R Revolutions or Python, but let me clarify and I will reply to that. Best tool for visualization? Well, depends is my answer, but yes, the great platforms, you have something free like Java, the JavaScript libraries like D3JS and others. You have Tableau, you have ClickView. It depends on how sophisticated you want your analysis to be and what level of skills are you need to invest into learning that, right? So it depends. There is nothing as a single tool which is the best. There are many competitive tools around there. So this is a function of many questions that come up, right? What kind of analytics technique can be done? I'm sorry, I am not able to understand your question. The question was, I have one question. What kind of analytic techniques that can be done? I believe the question may be incomplete. Or maybe no, I think what kind of data analytics is typically looked at in IT services domain? Well, IT services, you could use in your HR departments, in predicting the probability of projects completing on time, or whether they will be red or green or amber over a period of time, of in predicting defects, in predicting schedule slippages, in prediction of effort, in capacity modeling. Actually, there are many use cases. I'm going to give you a list of that. But yeah, you could use it in many scenarios in IT services, right? In fact, IT services have a huge volume of data. You could even do an analysis of survey text, especially, or customer survey analysis using text analytics there, to say that beyond the ratings, what are customers talking about? Very interesting results you will see, right? So that's something which would be very interesting to see also, right? Okay, so do excuse me if I miss some of the questions in the chat window. I would ensure that I reply to all of that. Will it be feasible to learn SAS, R, or Python for somebody who has no background for computers? I mean, who does not know SQL? Would it be feasible? Oh yes, it's always possible. You just have to spend a little more time. And I am definitely, if you put in the hours, it's not very difficult. And maybe you can start with something like R with Rattle, right, which is a UI-based tool, right? So you don't need to go into the SQL and other things, and slowly start graduating into R code, and then slowly do some level of you need to maybe understand SQL. You don't need SQL as a pretty large skill with you, right? So yeah, I'm sure it's possible. I don't think that's a huge challenge, right? And if you feel uncomfortable with coding, learn KNMIME. I'm sure it's a lot more easier than the coding part of it. You'll have some disadvantages, but I'm sure they will also evolve and take it further, right? What is the learning curve for somebody with a computer science background? Is the knowledge and statistics also required to be able to build better data analytics systems? Absolutely. Right, initially you might feel that somebody, one way is you might say that, okay, somebody is going to tell me what the model is and he'll give me the code for it. That's one way of doing it. But, without really understanding how it is working, you will have problems. So I'm sure you will need to learn it. Definitely level of statistics, and slowly as you start getting deeper and deeper into analytics, you'll also start learning subjects like information retrieval, cluster computing, and other things, because we're then going to talk about how fast your results will be fetched, and how can you partition data, and many other things. So you will need statistical knowledge to understand some of the algorithms, like how does a logistic regression work, how does a decision tree work, and things like that. So sure, you would need some stats, but yeah, it's not that you need all the stats in the first day. I always the question that is asked many times is similar to this, and I always reply telling that you don't need to learn everything on the first day. We can take that step gradually towards it, and definitely with time we'll pick up all essential things. Let's start solving problems which are near us, and then going forward. We have this beautiful system of Stack Overflow and Google and our communities, and there's a large number of people that you can just email, and I'm sure they will respond to you. So I don't think there's a problem in terms of starting off. How can people in the process line use data analytics more effectively, especially in high maturity and prediction models of CMMI level 5? I see a huge scope, but very little guidance is available. Yes, because CMMI kind of an improvement framework, it just tells what has to be done. You can virtually explode in that area here, because you can take all your project's data. You can take all your project data and start predicting, very interesting things. You can predict whether a project will be successful or not, whether the customer is going to rate you above 4 or 5 or not. You are going to predict whether, what is the number of defects you will get, what kind of capacity loading or people do you need at what points of time. You can do a lot of things. If you're talking about a level 5 kind of an element. Yes, but I mean, there is a little guidance available, but that's something that obviously I'm sure do drop in a mail to me, and I am sure we will I would get back to you on some of the areas that a little more in detail, and we can, always converse around that. Prerequisites for people to pursue, it seems very technical, and a need for people to be hands-on developers to pursue and use analytics. Very hands-on on developers, not really, but definitely. So you could actually, so it's like this, you need to be hands-on in one of the areas. You need to be a hands-on developer, or you need to be a hands-on statistics and maths guy, or you need to be hands-on in the domain, right? But you will have to acquire the information and knowledge of the other three as you go ahead into the journey. Right? So if you are somebody who's very good in the stats and the area, you could get your expertise around that. If you're very good in the domain element, you could definitely influence the decisions that are coming out, and that's very useful many times, right? So yes, there is a lot of technology required, but if you just step back and think of how it is going to be used, you will realize that yes, the technology is required, and the technology is not something extremely complex. I mean, there are people who, if you just reflect back, people have been coding systems coming out of colleges. Right? So it's not going to be complex, it's going to take a little time, but it's definitely feasible. But you have to have a solid grasp in one of the three domains, right? And slowly go into an intersection of three. Obviously, you may not become an expert in one of, and I take my example in this always. I'm not an expert in developing systems and all. In fact, I had left coding. I think the first year was when I first 6 months, 8 months were doing coding. After that, I've been purely into businesses, business functions, business optimization, consulting. I've been doing analytics for 6 years purely from a statistics and business perspective. But today, when I start thinking about how to be used in application, usage as a deployment element, I also have to understand the technology behind it. So I do understand what's going on, but that doesn't make me a developer, right? And so that's how the whole system will evolve. Most of the prediction modeling, next question, most of the prediction modeling currently being done for ML5 is using tools such as Crystal Ball. Do you think these can be replaced by tools such as mentioned in the webinar today? Absolutely, it can be replaced. And definitely, that's what we are doing with a lot of clients also, and definitely there's a lot of more advanced elements that you can bring in, which need not require Crystal Ball or Excel or many other things, but a lot more dynamic in their functionalities. Right. A lot of professional courses on market and analytics. It would be good to know the programs which are maybe available to organize, integrate. Yes, it will. When I send the mail, I will try to integrate a kind of set of courses that QAI also does, and you might find it useful to browse through it and see. We have been delivering a lot of courses for multiple companies, starting from IBM to Capgemini to Mercer and many other such companies. So you may have a look and take a call. Would you recommend for predictive of what tool and technique would you use for predictive analysis of project effort, schedule, and defect data? Well, you could. Well, you know what? I think you need to tell me the business problem rather than project effort defect. That's not the business problem. You want to identify. I could solve it using a classification problem also, telling that if I have a project effort overrun of greater than 4%, 20% or not. I could also solve it using a regression kind of an element. I could use neural networks to do that. So you could use a multiple set of techniques. It depends on the volume of data and the kind of output that you require. Right? Okay, the last one is, are SPSS or any other packages available online for learning and having hands-on? Definitely. There's a lot of courses, right, from Coursera to many other places. SPSS, you don't have to look for it. I'm not sure about that package. Are lots. There is a thing called Data Camp where we do it, and there are many other things also. SPSS, yeah, you have to look at it, right? QA also does a lot of R kind of courses. So my email ID is on the first page of the slide set, and I'm going to share this with you anyway. It's my full name. At arimaresearch.com. That's right at the bottom. And it would be great to connect with you on LinkedIn and other places. So let me know, and we can keep on talking. Okay, last question, and maybe the rest I would email it across to you. what are the relative strengths and weaknesses of choosing a more complex model over a simpler one? The computing power and the complexity and volume of data required would be more for a complex model, right? And of course, the need would be dependent on dependent on the business question that you want to answer, right? So if you want to do something like I want to categorize which two words occur together, obviously the model complexity is more rather than trying to identify how many times does satisfied appear in the whole customer feedback, right? So, and obviously the volume of data required will be slightly more. So you know, it's a function of the business problem, and obviously if it's a complex model, it will require slightly more data as well as you know a little more complexity of the solution also has to come in terms of the answer that you're looking. Great, right. So thank you very much. I hope you enjoyed this session. I hope it was also informative and useful to all of you. I think there will be a feedback form. I would request your suggestions, and if you liked it, do rate us. I'm going to have this presentation available as well as some other resources on a mail that I'm going to send out to you. So it would be great to keep in touch. In case you need to mail me, my mail address is available. Would be available on the first slide itself. It's Chinmay Pradhan, CHINMAYPRADHAN at Arima Research, ARIMARESERCH.com. Thank you again for attending this webinar. I have to thank QAI, our exclusive partners, and Praveen and Sonakshi there. They have been great help instead of setting this up and executing it out and helping me out with all of this. Right, so talk to you soon. Keep in touch. Thank you very much.